Hello, so this is a Jupyter Notebook for, demonstrating how DPC can work. This is using our ImSwitch client. You can go through it. It's basically an open source library that is adapting to the application protocol interface. So this is our ordinary microscope. You would know that. So this is the LED matrix. So it's only turning on in the red channel right now. And you can move around. So the sample is not quite ideal because it's in a multi-well plate, which is a 384 well plate. So you have all kinds of shadows if we process it later. Let's ignore that for now. And the microscope is connected to a remote machine over tail scale. And you see the application protocol interface using this here. So you can, for example, retrieve an image. So I know that it's snap to fast API. So then there's a NumPy array being returned. And then what we do right now is basically we trigger a snap of an image and then at the same time also change the illumination. So if you go through the different steps, as you would do that typically with a Jupyter Notebook, there are all kinds of helper functions. It basically acquires 4 different images with illumination from 4 different sides. So you can see that now, and everything's triggered from the Jupyter Notebook remotely. So the microscope is actually sitting 10 kilometers far away or 5 kilometers. And then the 4 images are stored, and then there's all kinds of warning messages processed using the DPC algorithms from LoRaWALLA essentially. So we have made some adjustments. The result's not quite looking right because, it's mostly because of the sample configuration right now, and also the parameter tuning is not correct. But this is basically how you can acquire DPC, FPM, and all these kind of things by basically calling the API, changing the illumination scheme, then tweaking the adapters, the parameters. So if you have any question, feel free to get back to us and tweak this Jupyter Notebook to your needs.